2 decimeter cubic vessel at 40 degrees Celsius. What is the pressure in the vessel? We know that molar mass of nitrogen gas is 28 gram per mole, and we can get the mole is from the formula gram divided by molar mass. So 1 gram of nitrogen gas divided by their molar mass, we got the result is 0.035 mole. And we can know the temperature is from the Celsius 40 degrees Celsius plus 273 Kelvin equals 330 Kelvin. Next, we are looking for the pressure, and we can know the pressure is from the formula mole times by R times by the temperature and divided by the volume. So we times the 0.035 times by 8.31 times by 313 divided by 0.002, and we got the result. Pressure is 45,518. And I run the answers to the C1 because it is the near. First question, under which condition will nitrogen behave most like an ideal gas? Real gas behave most like an ideal gas at high temperature and low pressure, because at high temperature molecules have high kinetic energy, low pressure keeps molecules far apart so their volume is negligible. A pure sample of a gas has a density of 2.62 gram decimeter cubic at 101 Pascal and 25 degrees Celsius. The gas behaves ideally under these conditions. This expression gives the molar mass of the gas. We know that the formula of density is mass divided by volume. So if we arrange the ideal gas formula with density formula, it will be like density times by gas constant times by temperature divided by pressure. Since the density formula is mass divided by volume, we put the mass and volume on the different place. So the molar mass equal mass times by gas constant times by temperature divided by pressure times by volume. So the answer is B. Why does ICl have a higher boiling point than Br2? ICl is a polar molecule because iodine and chlorine have a different electronegativities, and it's creating permanent dipole-dipole force, while Br2 is nonpolar and only has weaker London dispersion force. So the answer is B. Consider the following statement. First, silicon dioxide has a higher melting point than sulfur dioxide. Second, ammonia has a higher boiling point than phosphide, pH 3. Which statement are correct? Statement 1 state that silicon has higher melting point than sulfur dioxide is correct because SiO2 forms a strong giant covalent network, while SO2 consists of weak intermolecular bonds. Statement 2 states ammonia has a higher boiling point than phosphine, pH 3, is also correct because NH3 molecules are held together by strong hydrogen bonds, whereas pH 3 molecules only have weaker dipole-dipole force. So the answer is A. Both statement 1 and statement 2 are correct. Next, the diagram shows part of the lattice structure of solid X and Y, represent particles of different elements. We start from the Y1, the most iconic one, is hexagonal bonded atom, known as graphite structure, and graphite structure is of course giant covalent, while the X1 is 3D cubic arrangement, is typically for giant ionic arrangement. So the answer is B. X is for ionic and Y is for covalent. 47 grams of hydrocarbon is completely burned in air. The energy released heat 200 grams of water from 23.7 degrees Celsius to 41 degrees Celsius. What is the amount of energy absorbed in joules by the water? The first one, we calculate the temperature change. The 41 minus 23.7 is 17.3 degrees Celsius. Even if we convert it to Kelvin first, the value stays exactly 17.3, making option D mathematically is incorrect. Enthalpy change of combustion of carbon, hydrogen, and methanol are shown. Which expression gives the standard enthalpy change of formation of methanol in kilojoule per mole? So the formula of enthalpy change of combustion is reactants minus product. So we need to put the enthalpy change in the right So in this reaction, the reactant is the first and second reaction. To make 1 mole of methanol, we need 1 carbon. So it's exactly minus 394 kilojoule per mole, plus we need 2 hydrogens. Since one hydrogen molecule gives minus 286, we times it by 2. So 2 times minus 286 and minus the product, enthalpy change of product, minus 726 kilojoule per mole. So the right answer is C. Two standard enthalpy change of formation value are given. What is the enthalpy change for the reaction? 3 VCl2 become 2 VCl3 plus V. So the formula of enthalpy change of formation is enthalpy change reaction equal enthalpy change product minus enthalpy change reactant. The formula is different from the number 16 because this question asks for the enthalpy change of formation. So enthalpy change of product is, we use the minus 573 kilojoule per mole. It times by 2 because in the enthalpy change of reaction, the VCl3 is times by 2. Minus enthalpy change of reactant, which is minus 452, and we times it by 3 because in the reaction it's 3 FCl2. After we times it, we got the answer is minus 1146 minus 1356, and it's become plus 210 kilojoule per mole. So the right answer is D. Number 18. The average intermolecular force in water are much stronger than the average intermolecular force in steam. The average intermolecular force in ice are slightly stronger than the average intermolecular forces in water. The enthalpy changes are associated with the equilibrium process shown. H2O equilibrium with H2O, H2O equilibrium with H2O. Which statement are correct? The first one stands for enthalpy change for boiling, while the second one stands for melting. Let's see the first statement. The first statement says that enthalpy change boiling and enthalpy change melting are both negative. The answer is wrong because enthalpy change of boiling and melting are both endothermic processes because you must add heat energy to melt ice or boil water. So the both values must be positive, not negative. Statement 2. Enthalpy change boiling is greater than enthalpy change melting is correct because boiling liquid water into gas requires breaking all remaining intermolecular bonds completely. Melting ice only requires loosening the fixed structure. So the enthalpy change boiling requires a lot more energy than melting. Statement 3. The intermolecular force in ice and water are of the same type is correct because in all states of water, even it's ice, liquid, or steam, the particles are held together by the same primary force. It's hydrogen bonding. The equation for the formation of ammonia is shown. 3H2 plus N2 become 2NH3. The enthalpy change is minus 92.2 kJ per mole. Some bond energy data is given. Bond H and H have bond energy 436 kJ per mole. And N with nitrogen with hydrogen is 388. The first one is hydrogen with hydrogen. We know that the hydrogen bond have 3H2. So the bond energy is 436 times by 3. It's become 1308 kilojoule. And the second one, nitrogen with hydrogen. We can know by the equation 2NH3. 2 times by 3 is 6. So 8 times by 6. It's become 2328 kilojoules per mole. Now, we substitute our numbers into the main formula. The formula is enthalpy change equals bond broken minus bonds formed. Enthalpy change given is minus 92.2. 92.2 equals 1308 plus nitrogen bond. Let nitrogen bond become X. Minus 2000 minus 2328. Now substitute our number into the main formula. Given that enthalpy change is minus 92.2 kJ per mole equal 1308 plus nitrogen bond minus 2328. Let nitrogen bond become X. So minus 92.2 equal X minus 1020. X equal minus 22.2 plus 1020. So the X is 927.8. So X is 927.8. So the answer is B. Number 21. Sodium and sulfur react together to form sodium sulfide, Na2S. How do atomic radius and ion radius of sodium compare with those of sulfur? The right answer is D. The trend of Na and sulfur atomic radius is decreased because both sodium and sulfur are in period 3. As you move from the left to right across the period, atoms get smaller, so the sodium is greater in atomic size. But in ion radius, when they form ions, sodium loses an electron to become Na+, while sulfur gains electron to become S-2, S2-. Since sulfur has more shells, sulfur has a greater in ionic size, so their answer is D. 22. The relative magnitude of the property X of 5 elements is shown. P, Q, R, S, and T are all in period 3 and have consecutive atomic numbers. The letters are not the actual chemical symbols of the element. Which row is correct for property X and element R? Let's trace the 5 consecutive elements in period 3. P, S, Na, Q, S, Mg, R, S, Al, S, Si, and T, S, P. The trend of metallic bonding gets stronger from Na to Mg to Al because they contribute more delocalized electron. This makes electrical conductivity peak at aluminium. The drop right after aluminium comes with silicon, which is metalloid or semiconductor, causing the electrical conductivity to drop sharply at element S. So the right answer is A. Property X stands for electrical conductivity, and element R stands for aluminium. 12. In this high temperature of core engines, nitrogen reacts with oxygen and give nitrogen monoxide. Half of nitrogen plus half of oxygen become nitrogen oxide. The enthalpy change is positive 90 kJ per mole. The reaction has activation energy EA. Which reaction pathway diagram could correctly represent this reaction? The change is plus, so the reaction must be endothermic. So the answer of A and D is incorrect because A and D is for exothermic graph. How about the P1? It's also not correct because the energy activation is not start from the reactant line. So the right answer is C. Element X in period 3 has the following properties. First, its oxide has a giant structure. Second, it forms covalent bond with chlorine. Third, its oxide will neutralize HCl. What is element X? The right answer is B. Why is correct? Because the first clue, its oxide has a giant structure. Aluminum oxide forms a giant ionic lattice structure with a very high melting point. The second one, it's formed covalent bond with chlorine. When it reacts with chlorine, it's formed aluminium chloride, which uses covalent bonding rather than ionic bonding. And the third clue is oxide will neutralize HCl. Aluminum oxide is amphoteric, meaning it can act as both as a base or as an acid. Because it can act as a base, it reacts perfectly with HCl. So the answer is B. 25. Which substance does not give HCl when water is added to it? The answer is A. Why it is correct? Because on chemistry, when nonmetals covalent from period 3, which is Al to Cl6, SiCl4, and PCl5, react with water, they will undergo a reaction called hydrolysis. While there is a exception for MgCl, because when you add water to it, it simply dissolves in individual ions. So it does not undergo heavy hydrolysis and it does not give off HCl gas. 26. The element in period 3 and their compositions trends across the period from sodium to sulfur. Which row is correct? Electronegativities from sodium to sulfur, nucleus get more positive protons, so the electronegativities is increased. But from the acid and base behavior, metal on the left it's Al2O3 to non-metal. Metal on the left is basics, Al2O3 is amphoteric, and non-metal is acid. So the right answer is C. 30. Two period 3 elements, X and Y, burn separately on oxygen to form solid oxides. The oxide of X is insoluble in water. The oxide of Y dissolves in water to form a solution which dissolves the oxide of X. What could X and Y be? The first clue is oxide of X is insoluble in water, which will make the answer C and D is incorrect because silicon is soluble in water. So the answer of silicon. C and D is incorrect. The second clue is the oxide Y dissolved in water to form a solution which dissolves in the oxide of X. Sodium burns to form sodium oxide. It dissolves in water to make strong alkaline solution. Aluminium oxide is amphoteric, so it can react with sodium. So the right answer is A, because aluminium can react with sodium because it's amphoteric. Sodium is more reactive than magnesium. It reacts with acid much faster. So it's wrong. The B option states that 1 mole of magnesium carbonate gives off a greater amount of gas when it reacts with an excess of dilute hydrochloric acid than 1 mole of barium carbonate does. Is wrong, because both carbonates produce the exact same amount of carbon dioxide gas. Is 1 mole of gas or 1 mole of carbonate. Let's see the D1. State that magnesium carbonate undergoes thermal decomposition less readily than barium carbonate does is also wrong, because magnesium carbonate breaks down with heat much more easily than barium carbonate does. So the right answer is C. The solubility of magnesium sulfate in water is greater than the solubility of barium sulfate in water. 36. An excess of MgO is shaken with water. The resulting mixture is filtered into test tube X. An excess of BaO is shaken with water. The resulting mixture is filtered into test tube Y, which oxides reacts more readily with water and which filtered has the lower pH. Oxide reacts more readily with water. Ba is lower down in group 2 than magnesium. The reactivity of group 2 oxides with water increases down the group, so the barium oxide reacts more readily and rapidly in water. The second one, test tube with filtered of lower pH. The magnesium hydroxide formed in test tube X is only slightly soluble in water, making it a weak alkaline solution. The barium hydroxide formed in a test tube Y is much more soluble, making it a stronger alkaline solution. So, the right answer is A, because the barium oxide reacts more readily with water, and Mg is half the test tube with lower pH than barium. W is a solid that reacts with water to produce an alkaline solution. The addition of 2 drops of dilute H2SO4 to this alkaline solution produces a white precipitate. What could be the identity of solid W? The answer A and B are wrong. Magnesium hydroxide and magnesium oxide are barely soluble in water, but not dissolve easily to form clear alkaline. The option is also non-correct, because phosphoroxide is a non-metal oxide. It reacts with water to form an acidic solution, not an alkaline solution. So the right answer is B. Is C. Sorry, the right answer is C. Is barium oxide, because barium oxide reacts rapidly with water to form BaOH2 and gives a white precipitate result. And now we continue to the paper 2. On the first page is the first question. I'm gonna review the first question. 1A. Both carbon monoxide and nitrogen are gases at room temperature and pressure. They both behave like ideal gases under certain conditions. 1. State the 2 conditions necessary for these 2 gases to approach ideal gas behavior. The first one, high temperature, because in high temperature they will have high kinetic energy. The second one is low pressure. When the pressure is low, the particle gas will fall apart. 2. Explain why nitrogen gas behave more like ideal gas than CO does at 20 degrees Celsius and 101 kilopascal. The answer is because ideal gas should have no attractions. Nitrogen is a non-polar molecule with weak London dissipation forces, while CO is polar, so weaker forces in nitrogen make it more ideal. B. Calculate the amount in mole of pure nitrogen gas which occupies 100 cm cubic at 101 kilopascal and 20 degrees Celsius. Use relevant information from the data booklet. Show your working. So, first we convert the 101 kilopascal to the pascal, so it becomes 101,000 Pascal, and then 100 centimeter cubic. We convert it to the meter cubic, so the answer is, the result is 0.0001 meter cubic. We're looking for the mole, so we use the formula PV divided by RT. So we multiply the pressure with the volume, and we got the answer is 10.1, and we also times the gas constant with the temperature, so we got the answer is 2434.8. We divide it together, so we got the answer is 4.1 times by 10 power of minus 3. C. Diamond and graphite are both crystalline solids. Diamond and graphite are both crystalline solids made from carbon atoms. Graphite conducts electricity. Diamond does not conduct electricity. Name the type 1. Name the C1. Name the type of lattice structure present in the crystalline solids diamond and graphite. The answer is ion covalent. C2. Explain how graphite conducts electricity. The answer: graphite has C of the localized electron, which allow electron to move around. C3. Explain why diamond does not conduct electricity. It's because diamond doesn't have the localized electron. D. The strength of interaction between particles determines whether the substance is solid, liquid, or gas at room temperature. Lithium sulfide, I2S, is a crystalline solid with a melting point of 938 degrees Celsius. It conducts electricity when it is molten. 1. Give the formula of the particle present in solid lithium sulfide. The answer is lithium plus and sulfur minus 2. D2. Explain in terms of the structure of the crystalline solid. While lithium sulfide has a high melting point, it's because lithium sulfide has a giant ionic lattice structure, so they need a high of melting point. Second question. Two. The period 3 elements show trends in physical and chemical properties across the period. A. 1. Explain why the elements Na to Al are good electrical conductors. Answers. It's because Na to Al has metallic structure with delocalized electron. A2. Explain why the elements P, S, and Cl do not conduct electricity. P, S, and Cl have simple molecular with no delocalized electron. B. Look at the figure 2.1. Shows the variation in melting point of the period 3 element Si to Cl. The period 3 elements Si to Cl are all nonmetals. Explain why there is a large difference between the melting point of Si and the melting points of P, S, and Cl. Answers. Si has a giant covalent structure, means they need a huge amount of energy to break, while P, S, and Cl have only simple molecular structure, so they only need a little heat energy. C. Table 1.3 gives some information about MgCl2 and SiCl4. MgCl2, electrical conductivity when liquid is conduct, but observation when added to water it dissolves. SiCl4, when the electrical conductivity when liquid doesn't conduct, and observation when added to water is Figoro's reaction. C1. Explain the difference between the electrical conductivity of liquid MgCl2 and of a liquid SiCl4. Revert to bonding and relevant particles in your answers. Liquid MgCl2 can conduct electricity because it has ionic bonding, while liquid SiCl4 cannot conduct electricity because it has covalent bonding and neutral simple molecules. C2. Suggest the pH of the solution that's formed when each chloride is added to water. MgCl2 has pH 6.5 until 7, while SiCl4 has pH 1 until 3. Next, we move to the last questions. Number 3. Separate the sample of Na2CO3 and NaHCO3 reacts with HCl to produce the same product, as shown in table. A. Complete the reaction pathway diagram in figure 2.1 for reaction 2. Reaction 2 has an enthalpy change plus 27 minus 2. There was a plus sign, so its reaction is endothermic. On the graph, I draw the product line NaCl H2O and Cl2 at a higher energy level than the given reactance line. Draw the curve here rising from the reactance up to peak and then coming down slightly settled on the product line. Put the label energy activation upwards from the reactant energy level to the very top peak of the curve. Label enthalpy change to is vertical arrow pointing upwards from the reactant energy level directly to the product energy level. So this diagram is correct. B. The value of enthalpy change 1 is determined by experiment using the following method. 50 cm cubic of 2 mole of decimeter cubic HCl is added to a polyester cup. The initial temperature of the acid is recorded as 19.6 degrees Celsius. 0.0400 mole of Na2CO3 is added and the mixture is stirred. All solid and A2CO3 is separated and a colorless solution is produced. The maximum temperature recorded during the reaction is 26.2 degrees Celsius. B1. Describe one other observation that shows the reaction is complete. Evanescence stops. The answer is evanescence stop, or we can say fizzing or the bubbling stops, or the more gas is evolved. B second. Calculate the value of enthalpy change 1 in kilojoule per mole. Assume that specific heat capacity of the reaction mixture is the same for water and not heat is lost the surroundings. Show you working. First, we're looking for the temperature change. We got it. The temperature change is 6.6. And right now we calculate the calor. So we use the formula mass time by C times by temperature change equals 15 times by 4.18 times by 6.6. The answer of calor is 1378.4. Find the enthalpy change value. Enthalpy change formula is minus calor divided by mole. We got the calor value is 1379.4 divided by 0.0400. So the answer is minus 334.4 kilojoule per mole. B3. Thermal decomposition occurs when NaHCO3 is heated. Reaction 3. 2NaHCO3 plus Na2CO3 plus H2O plus CO2. Calculate the enthalpy change for reaction 3. Enthalpy change using the data in table 2.1 and the value of enthalpy change 1. Calculate in. So we write down the reaction on the table 2.1, but we samain urutannya. Like in the first reaction, the Na2CO3 was in the reactant, but on the way of the solving problems, the NO2CO3 is become in product line. So we also change the value of the enthalpy change. The enthalpy change is become minus, not positive anymore. We do the same thing to the reaction 2. We write down the reaction 2, but on the reaction 3, the 2NaHCO3 is already on the reactant side, so we didn't need to change or switch the position. But on the reaction 3, the NaHCO3 is have coefficient 2, so we need to add 2HCl become 2NaCl plus 2H2O plus 2CO2. And then we eliminated the element have the same amount of self-exact element with the first reaction, like 2NaCl eliminated with the 2NaCl, 1 H2O with 1 H2O, 1 CO2 with 1 CO2, 2 HCl with 2 HCl. And the product become 2NaHCO2 become NO2 CO3 plus H2O plus CO2. So we got the answer of the value is plus 88.8 kilojoule per mole. That's the last question I have answered. Thank you for your attention, and I'm really sorry because there were so many mistakes I have made. So thank you so much everyone, and goodbye.